Okay, the next system we're going to look at is solid set. So that's the page you just got. And we'll just go right through it. Now we've seen all these components already. And we start with the main line. Solid set main line. What are we going to be dealing with? The product of choice will be PVC for the main lines. Reason for PVC, cost. Generally, we're not looking at huge main lines, but where we do run into very large main lines, we'll have to go to steel. Solid set does not run at high pressure. Most of these solid set sprinklers will run no more than 50 or 60 psi, and that's really high pressure. Most solid set systems are going to be 40 psi or less, down to 25 psi, maybe even lower than that. And every year there's new product coming online that is looking at lower pressures that can still get droplet size and application radius that they're after. Another reason for PVC mainline is that it doesn't rust. So you don't have particles of rust chipping off from the inside of the pipe, then ending up going out through the sprinklers and plugging up nozzles. So you sure want to make sure that you don't run into plugging problems due to the mainline deterioration. So we're going to deliver water out to the field. Then what we do in solid set is we end up creating blocks of sprinklers. So a whole block will come on at a time. Not just one lateral, not one row, but generally a whole group of rows in a common location. And so we call that then manifolding. So we will have a main line coming through a field. We'll make that the main line. And then off that main line will come in and we will have blocks of laterals that come off of that main line on either side of that main line. And we'll call these manifolds. So the screen will be manifolds. This field happens to have 10 manifolds, just because that's the way it ended up getting drawn on the board. Now those manifolds are going to be hooked up to that main line with a valve. So we'll put little valves on these guys, and we'll generally do them right in the middle. So we're going to link right into the middle of the manifold with a valve. So those guys are valves. Now that manifold is going to be made out of plastic also. We're going to size that manifold to accommodate the amount of flow that's going to be coming through the pipe into that block. Now we call it a block, and each one of these manifolds then will have rows of sprinklers coming off of it to the edge of the field. However many makes up the right amount, you know, and so on. That's a design criteria to decide how many and how long. But out here at the edge of the field, these are all then the laterals. In blue. Okay, now we have the system pretty well laid out. All the piping is there now. We got everything in the field. And of course, there'd be a whole block of laterals on each of these manifolds. They'd all look like this. Just mirror image those. There'll be 10 of those. We call that whole thing a block. So we're going to run a block of sprinklers at a time. This valve will turn on. It'll water all of those sprinklers in that block all at one time. So all I need to do is have a way, and I can automate this thing, put a controller out there, 10-station controller, and this thing's going to take care of itself. It'll just do its thing. Now the main line is sized big enough to water any given block. So as I come down, the main line is going to be the same size through the whole field because every block requires the same amount of water. So say that this block required, how many lines I got in there? 9 lines. Let's say it required 450 gallons a minute. Well, when this block here runs, it needs 450 gallons a minute just coming that far. Then I cycle to this block, 450 gallons comes to here. Nothing's flowing down here, so I wouldn't need any main line at that moment, but I'm going to eventually, so it has to be there. But 450 gallons a minute flowed from wherever the pump delivery is to that block, and so on. 450 has to be able to come to here, or to the far end. So the flow rate is going to be 450 gallons a minute anywhere in that main line. So I must maintain a size to handle 450 gallons a minute. Okay?
That'd be minus friction loss, right?
Then that would create, well, there will be friction loss in that main line. So there will be a, depending on the elevation, there will be pressure loss due to friction from one end of the main line to the other. Absolutely. But we design for that. We size the main line so that we minimize that loss. And then it would have an effect also on the topography, the slope of this unit. If it's going downhill, then we gain pressure because of the hill. You know, going downhill, you gain pressure. If we're having to push it uphill, we're going to lose a little pressure. So we have to look into that too. Now we're going to get into hydraulics in another week or so, and we'll really look at those concepts as well. It's a good point.
So would you vary the size of your laterals or just the sprinkler heads themselves?
Oh, we want every block to be identical. So they're all going to run the same.
For the compensation of friction, you wouldn't.
We're going to size it up, pressured enough so that it overcomes any of the friction loss in the system.
So at the start, it'd be a little bit of an overkill?
Well, it's going to be a little higher at the start. Again, depending on the slope. Say this whole thing's flat. Assume it's a flat field. The pressure is going to be highest right here. Because every foot we go, we're going to lose a little bit of loss in pressure. Well, what we do is we manage how much we are allowed to lose by sizing the pipe accordingly. We keep the pipe big enough so that we lose very little pressure. And we might say our minimum loss will be 5% at the farthest point out here on either end of one of these blocks. So we size our main line, manifold, and lateral so we lose no more than 5% of the pressure. So if we started up here at 40% or 40 psi, 5% would be 2 psi. That's all we'd say we'd allow ourselves to lose. We'd have to size everything accordingly. A little bit ideal. I mean, we're going to lose more than that, but that would be a little ideal.